start the recorder and continue from where we left off last time. Okay. So are there any questions about how to put your PC together? Any questions about components that we talked about last time? Any questions about the motherboard or the processor, or how you can select the processor, or what is the trade-off between spending more money today to buy the faster processor versus just waiting in terms of time for technology to improve? Are there any questions about those discussions? No questions? All right. So I'm not sure, I think we did not really have a section that talks about it. I kind of talked about it verbally, but this part here is, has been there since Tuesday, but I think I never really got to this point. It talks about the different quote-unquote types of technology in modern processors. So in other words, why do you want to pay more for an i7 processor when an i5 processor may have the same number of cores and have about the same performance in general? So what are you buying with an i7 processor by spending an extra maybe $100 or $50 depending on the version? Okay, the first thing about the i5 and the i7 processor from Intel, and I'm thinking that AMD probably has a similar technology. No? Okay, so these are all Intel i family type of technology. So Turbo Boost is what they call, Turbo Boost is a technology where they can just crank up the clock speed internal to the processor for as long as the processor can stay within a temperature range. Yep.
AMD does have something like that, actually.
AMD has something like that too.
Yeah.
Okay.
It's called Turbo, just as well.
Okay. But it's not intended to be run at full time. So in other words, they can only crank up the performance for as long as the processor can stay within a certain parameter of a certain range of parameters, based on temperature, current draw, and so on and so forth. Okay. So if you're working on something that only requires bursts of improvement of performance, this will be helpful. If you're running a game, I really doubt it is that helpful, because with games, they constantly need all that processing power. So you cannot just run on Turbo Boost forever. Hyper-threading, here we have a link to the Wikipedia discussion. So I looked it up, and it's kind of interesting. Hyper-threading, once you have hyper-thread, it makes the pretense that you have more cores, but that really is not the case. Okay, so when you have an i7 processor with 4 cores, it still only has 4 physical cores, but with hyper-threading, it will report to the operating system that it has 8 cores. So the way it works is like this. When you're working on a particular program, there are points of time where an operation cannot continue because it has to wait for a lengthy operation to finish first. Okay, so if you have one single core without hyper-threading technology, then that one single core will be stalled. Okay, we call it being stalled because it's waiting for access to memory or some other things that are really slow, and it's just waiting. Okay, so with hyper-threading, what is happening is the processor core or the processor die itself will recognize and say, oh, I'm stalling on this particular thread, but this other thread is ready to go. So it will basically reorder operations so that it will try to utilize the hardware as much as possible. The performance gain claimed by Intel with hyper-threading is about 30% in general. So with hyper-threading, your processor, at the same clock speed, everything else being the same, will be about 30% faster than a processor without hyper-threading technology. Okay, so those numbers are quoted from Intel itself. Yep.
When you say threading, you mean taking another route?
No, threading, generally speaking, one thread is a sequential execution sequence. Okay, so with 8 threads, it means the processor in hardware can keep track of 8 parallel sequences of operations at the same time, and it can reorder things a little bit just so that it can maximize the utilization of processing resources.
But when it's stalling, is it waiting for some other command from somewhere else on the motherboard? So if there's a bottleneck somewhere else that processor?
The stalling mostly has to do with either lengthy operation, like you have a long floating point calculation to complete. So the FPU, the floating point unit, is stalled. Okay, it is doing its own operation, but you cannot proceed after that point because the next operation may rely on the result of the floating point calculation. But one single core has multiple, I should say, multiple units to do calculations. So you have multiple floating point units and you have multiple integer units that can all operate at the same time. So just because one sequence relies on a floating point calculation in order to proceed doesn't mean the other one, is relying on the same floating point calculation. The other one may only need to do integer calculations. So that one can actually utilize a separate part of the same core to do integer calculation. So you can have two things going on at the same time, whereas without hyper-threading technology, it would be stalled. Okay, you cannot move on until the floating point calculation is done.
So the process is utilizing it's maximizing its processing power.
It's trying its best to maximize the utilization of available processing resources without intervention from the operating system itself. Yep. So you're gaining about 30% according to Intel, using the hyper-threading technology. And the turbo boost gives you another maybe 10% or so of performance gain when the temperature of the process is cool enough. So these two are basically, when you look at turbo boost and hyper-threading, I think combined you can expect maybe 50% of improvement, 50 to 60% of improvement over something that does not have both of these technology. Now the next one is not something that will benefit most people. Most people look at virtualization acceleration and go, I don't really need that. And that is true for the most part. On the other hand, if you want to run virtual machines, this is crucial. Okay, a lot of virtual machines will run without acceleration, but they'll be running a lot slower. Okay. Are there any questions about what is a virtualization? No questions? Or do you guys want? How many people understand what virtualization is? Okay. All right. So I will explain that a little bit just so that we know what it is. You had a question?
I was going to ask you. So if you want to run an old program, virtualization will help you do that.
It can run an old operating system. You can basically install anything you want, as a PC. It's kind of like a software PC inside a hardware PC, but you can run multiple software PCs, at the same time. So that's why it's actually beneficial to some people. If you have that need to run multiple operating systems at the same time, it is useful.
I was thinking more like an old game. If you try to run it now, because the processor makes it run quicker versus.
It'll still be way faster than what it used to.
If you want to slow it down.
You can't really slow it down. There's no control. There's no dial to control the actual speed of the virtual machine. So it will still run as fast as it possibly can. Okay. But to other people, especially if you're into computer administration, you have to do certain homework assignments on networking stuff. Virtualization is a very beneficial technology. Yep.
The turbo boost in the hyper-threading virtualization, what kind of operation system is that? When was the first time that they applied that?
Say again?
When was the first time that we see the turbo boost?
Uh-huh.
What kind of operation system? Because I remember that I used to have XP. Well, before XP, there was another thing that actually 95.
Well, turbo boost can benefit anything.
Yeah, but when it was loading, I remember still that I have to wait all the threading to start loading. When it was full, I have to.
You mean when the system is starting up?
Yes, that was long time ago, but now anymore I don't see that.
All that stuff is still happening in the background. Whether you can see it or not is a different story.
We used to see it in the interface, right?
Windows, has a GUI, a splash screen that hides all the other stuff in the background. Whereas Linux, you can see that when I start this system up, it spews out all kinds of,
Yeah.
messages.
That
Windows
was nice.
just put a splash screen on top of all that stuff, so you don't normally see that stuff happening, and that has nothing to do with the Turbo Boost technology. Yeah, in fact, with these technologies won't help you much when you're starting up a system, because your system is actually reading a lot from the hard drive. So for the most part, when you're starting up a computer system, an operating system, your hard drive speed, dictates, how fast you can start up, not really so much the processing resources. And these are, pure processing resources. Okay. Turbo Boost, can basically help with just about any type of application. Whether it's a single-threaded program or something that can utilize multiple threads, it doesn't matter. Turbo Boost can help with that because it's really just cranking up the processing speed. Hyper-threading can only help when you have programs that can utilize multiple threads. Okay, if you are not running any program that can utilize multiple threads, then multi-threading or hyper-threading or multiple core does not help at all. Virtualization only helps when you're running virtualization or virtual machines. If you're not using virtual machines, this technology is usually even turned off by the BIOS. Okay, so you have to actually enable it, even though your processor has the ability to do it. I'll just do a quick demonstration of what it is, what virtualization is about. So what I'll do is I'm gonna switch to a separate screen here, and I have to find out where my live CD is located at. Okay, it's over at SDC1. Okay, so this is what it is like. I'm doing this in Linux, but you can do it in Windows as well. Okay. All right. Don't mind about the actual command line, the command that I'm running here, because unless you have the same type of program installed, you won't be able to run it like this. But the technology is the same. Okay, so just kind of focus on the concept. I'll fail to initialize KVM. Fine. Okay, so we have to. See, on this computer, it has the processor is capable of virtualization virtualization acceleration, but it was turned off by the BIOS, and that's why it doesn't have that technology. I just have to find out how to TCG is what I want. Machine type is PC. Excel is TCG. Machine's a PC. I forgot about the syntax again. Okay, machine type is PC, and then Excel is, okay, we keep this screen here. KVM-M512-. Okay, there we go. I should start up. So when you focus on this part of the screen, this looks just like a normal PC when it starts up. I think I made a poo-poo here, and that's why it would not start up. But basically, I'm running a PC inside a PC. This box here is a physical PC, but what you're seeing here is an emulated PC within a physical PC. So you can actually install Windows if you want to inside this virtual environment. In other words, I can be running Linux on the outside, but in the inside, I can be running a Windows operating system as if it is just an application program. Yep.
So you can install Windows inside Linux?
Correct, or vice versa. You can run Windows natively, and when it's time for you to play with or experiment with Linux, you can use a virtual machine to run Linux inside Windows, and you can run both at the same time. This way, you don't have to dual boot. Yep.
Would that apply also to Mac OS?
Yes, it would. Well, Mac OS is a little bit different because you have to you have to factor in whether the BIOS of a Mac OS, a Macintosh can be emulated. I have no experience running Mac OS 10 using an emulator, so I cannot say anything about it. But it's definitely possible. You just have to have the right setup to do it.
Macs can emulate PCs.
Right.
You can run Windows inside a Mac.
Yep, but I'm not sure about the reverse.
I think
So
you
with
can.
Windows running inside of a Mac, is that virtualization or is that an app?
It appears as an app, but the app itself is a PC. It's the environment of a PC. So the virtual PC, which is not actually real, but to the PC itself, to the operating system running inside a virtual machine, it has access to a network card, audio card, graphics card. So to the operating system applications inside the virtual machine, it is as if they are actually on a physical machine, but they are actually not. Okay, everything is actually pretended or emulated in this case. Yep.
VMware or virtual PC allows you to run Mac OS on a PC.
Oh, okay.
What was that? Can you repeat that, please?
He said that VMware, which is a commercial emulator technology, can actually emulate the hardware of a Mac, basically. Is that okay? Okay. Okay.
When you talk about Office, Microsoft Office, I remember, I think it was on Excel.
Okay.
And one of the two references, if you look at that, they say you want any area, that's the same.
I don't think Excel has anything to do with emulation, not in the same sense that we are talking about. Okay. Yep. Okay. So right now, what are you seeing here? When you look at this little window here, what are you seeing? It's QEMU, on the title bar. But what are you? Let me just move this to another workspace, just so that it is not distracted. So we are not distracted by the background. Okay, it's still kind of distracting, but that's okay. All right. So what are you seeing here? Do you recognize this screen? Kind of. Sometimes when I start up the machine, the projector is already on, and this is the boot screen that you see when I start up the live environment. Okay. This is emulated. In other words, what you're seeing here is a virtualization of a PC running the same live environment that I'm usually running. So it's kind of nested. Now, if I start this up, using anything, you can see that it starts up. This is exactly what we usually see at the beginning of the class when I start up the live environment, and that's because inside this emulator, it is just like a normal PC. Okay, so I'm running a PC inside a PC, so to speak. Now this has the virtualization acceleration disabled by the BIOS. So this is actually running a lot slower than it should, because it could be a lot faster when I have the acceleration technology turned on. Now this has a lot of implications. If you really kind of think about it, it has a lot of implications, because what would be the disk drive used by a virtual PC like this, a virtual machine? Well, you can actually assign, go ahead.
Usually with virtual machines I've used, it's usually either some sort of ISO file or another folder that's specified specifically, so that's all the VirtualBox can access. It can't access anything outside of its
Exactly.
designated file.
Yep. In other words, the hard drive of the virtual machine is nothing more than a huge regular file to the environment that is outside of the virtualization. Okay. Now there's a big implication, because now what I can do is I can put the image file. Okay, I'm just using a prop here. I can put, depending on the size of the virtual, image file, if it is something that is relatively small, I can put it onto a thumb drive. Okay, so my virtual machine can now travel with me. Okay, now what can I do with my virtual machine? What can I install with my virtual machine? It's still loading because of the lack of acceleration. But what can I install? Okay, I can install anything that you can normally install on a normal PC. Okay, I can install Linux if I want to. I can install Windows 7, Windows XP, Windows 8, Windows Server 2013. Okay, I can install BSD, Berkeley standard distribution, I can install anything that you can normally install on a physical PC as an operating system. Now, on top of the operating system, what can I install? Microsoft Office. I can install Adobe. Yep, go ahead.
So you can take current things, you said 2013, and put it on an old.
Put it on, make it virtual. I can virtualize, with VMware, you can actually
Right,
virtualize.
so you can use that on an old computer.
No, you don't want to do that because that would just make it run extremely slow. But what you can do is, let's say you have an old PC that you have been using for years, okay? It has been running XP, but it has all the applications that you really need running on it, and you don't want to upgrade it because if you upgrade it, you have to reinstall the software, and some of those may not even be available anymore, okay? And it's on a big clunky desktop computer, all right? So this is your situation. You have an old PC with all the software, all the data files, and everything that you really want to keep using, except the PC itself is dying just because of its age. Okay. So how do you think your virtualization can help in this case? You virtualize the whole thing.
And then you take it to wherever
You can take it to any computer and run it as if it is just an application in the computer. Go ahead.
I was gonna say, you could just make an image of the hard drive and then virtualize the
Yep.
operating system on a different computer.
Yep, exactly. Yep.
So if I understand you correctly, everything on your old computer, you can virtualize it and put it on a different computer, work on it on a different computer, or can you reinstall it on the
Once you virtualize your old PC, it is nothing more than it's just like running an application.
That's assuming your flash drive is big enough, as big as the hard drive, though, correct?
Yeah, but what was the size of the hard? What is a regular size of a hard drive when Windows XP was still around?
So I think the maximum was like 60 to 80.
60 to 80 gig, okay? And now you can buy a 1 terabyte, external hard drive that you can just take with you anytime you want.
My first Windows XP computer was 6 gigabytes.
Okay. Yeah, 6 gigabytes would fit into something like this. This is a 16 gig, thumb drive. Okay. So the nice thing about that is now we can virtualize, an older PC, and run it as an application program. Okay, you can plug this thing into any modern PC, just plug it in, double click on an icon, and start running your old PC as if it is just a program. And then inside that PC, you still have everything. Every software that you install, all the data files and everything, they're all preserved. Okay, yep, go ahead.
How do you do that? I mean, just like a regular, flash drive to insert it, because I got 1 terabyte.
Uh-huh.
I transfer there, you see there.
I gotta show you this. Okay, because this one, what I'm doing right now is not really a good demonstration because I'm running Linux within Linux, so that's not very exciting, right? I mean this. Okay, so what I'll do is I'm gonna change this one a little bit, and let me go to my other drives. Let's see.
You want to pass out the motion?
Oh, that's right. Almost forgot. Thank you for the reminder. Yep. Okay, so I have a drive for that is labeled for Win. Okay, so inside for Win, I have a folder for XP. Just look at these files. Okay, just look at these files. I have TT 2011, TT 2012 .iso. That's TurboTax. Okay, I do all my TurboTax stuff inside a virtual machine. And this is an ISO file. In other words, I take the CD-ROM that comes with TurboTax and extract the entire CD-ROM into an ISO file. And you can see the ISO file is only about 423 megabytes, which by today's standard is not much. Okay, it's relatively small. Okay, I wouldn't call it tiny, but it's not a big file. And then you can look at hd.img. This is a hard drive image file. It's about 40 gigabytes, okay? And that file, which is only seen as a single file from this perspective, is serving as an entire hard disk drive to the virtual machine. Are we doing okay so far in the concept? Okay, so in the virtual machine, everything is pretended, right? And this file is basically it is used to pretend to be the actual hard drive to the virtual machine. Okay, I have various scripts here. The sh files are scripts for Linux. Interesting. I don't have a batch file to start this up in Windows, but who cares? I just received an email from one of my colleagues, that basically says Windows is going to die soon. Yep. Go ahead.
I guess now just hearing about it, I kind of didn't realize, is when you mount an ISO, is that actually a different form of virtualization?
No, it is not a virtualization in that case. It is really just your file system playing a trick. It's kind of like a.
It is virtualizing hardware, so I thought maybe.
It's a concept that is new in Windows, but in Linux land, we have been doing that kind of thing for many years.
Everything's a little bit different.
Yep. Everything is already done in Linux land when it's newly introduced
It's
in
just really
Windows.
complicated sometimes.
Right. But it is a pretense, yes. So you can look at it as a pretense because you're looking at one single file from one perspective, which is the .iso file. But once you mount it as a CD-ROM, then you can actually see all the files inside the CD-ROM as if it is a real CD-ROM. But except you can access it a lot faster because you don't have the seek time normally associated with an optical drive.
Well, not only that, but if you don't have the actual disk, rather than having to burn it, you can just have the ISO.
Yep. All right, so what I'll do here is I'm going to run my virtual machine using my script. Okay. And I'll run it with the TT1, so I will actually have the TurboTax CD-ROM as a part of the entire thing. And it's complaining because of the same thing. Okay, so we'll change that a little bit. Machine type is PC, and then acceleration is look for KVM first. If it is not available, look for TCG. I think that's the syntax to do it. There we go. All right, so I'm running this virtual machine right now, and let's see whether you can recognize this particular splash screen. I'm running XP inside Linux. Okay, and to Windows XP, to this particular installation of Windows XP, it doesn't even know that it is inside a virtual machine. It thinks it is actually running from inside a regular PC. This is my defragmentation program that runs before the system starts up, so it can defrag files that are normally not defragable because by the time you get to it, it's already loaded, and the defragmentation program inside Windows cannot do anything about it. And we can. Okay.
It's defragmenting the little file that you have allocated to it.
Sorry?
Is it defragmenting the little file that it has allocated then? It's a virtual machine, right?
It's inside the virtual machine, so it's not defragmenting any file from the host environment's
That's what I'm saying,
perspective.
you said it has a little file.
Yep.
It's just doing that file.
Yep, it's doing things inside that file because even though from the Linux perspective, it's a single file, from the virtual machine's perspective, that's the entire drive.
Well, yeah, it doesn't even know.
Yep, it doesn't even know it's a single file from the other side. Yep. Go
Where
ahead.
did you find that program? Ultra defrag?
Just ultra defrag. Just search for ultra defrag. Okay.
Is it already installed in the computer,
No, you have to download and install it, but it's free. Yep.
Would there be any benefit to having a hard drive image file defragmented?
Yes.
In the
That's a
actual
good
virtual
question
machine?
because inside the virtual machine, it doesn't have a physical organization anymore, so it may not be that beneficial. Actually, you're right. That's definitely right. Well, if they're on the same track, it still helps because everything on the same track is still sequential inside the file itself, so it will still help a little bit. So for those of you who want to defrag your hard drive, I use this particular open source program. Now, open source is kind of nice in two ways because one, it is free. Okay, you can download this for free and install it on as many computers as you want. And then the second thing is, if you worry about this program having some kind of hacks or malicious code in it, being open source means anyone can look at the source code and try to figure out, okay, is this really malicious and contain malware inside it or not? Okay, so from the security standpoint, it's an interesting thing. It's transparent. Okay, I should put it this way: it's transparent. So you just go to the download link here, and then depending on whether you're running a 32-bit or 64-bit operating system, you just pick the right version to download. So while this one is loading, I can switch back to the other side. It's still doing the defragmentation. I can type Control break to stop that. There we go. Yep, go ahead.
So when you have an old computer that you virtualize, transport it to another computer, does it access the same hardware, the graphic, the video card?
That's the tricky part. Okay, that really is the tricky part. In Windows, if you switch hardware enough, it will basically say, oh, I think I'm running on a different PC, and then you have to call up Microsoft to get a reauthorization to run your operating system. So it is possible that in the process of virtualization, you will see a screen popping up and say that you have to contact Microsoft again to get activated again. But you can see that it's running everything just like normal. And I can log in now. This is basically Windows XP running inside a virtual machine inside Linux. And this is why you want virtualization acceleration technology, because it can make this run a lot faster. It is now without the acceleration technology, so things are a little bit sluggish. But with the right hardware, even by Q6600 processor, which is a really old quad-core processor by today's standard, I was able to watch Netflix inside a virtual machine, inside the very same virtual machine that we are seeing here, without a whole lot of lag or stuttering. So I think that's useful. So you see the usual things. This is just like Windows, except it is being run as if it is just an application like Microsoft Word inside the Linux environment. Yep.
Okay, one more question. So if you reformat inside a virtual drive, does that delete the file?
Okay, you have to be more specific. What do you mean by that?
Well, usually on a computer, when you reformat the computer, you reformat the hard drive and
Yeah.
you install the operating system and all that. If you reformat a virtual Windows,
The disk image, you mean? The disk image file itself, or
Yeah.
inside here I do the reformat?
yeah, you inside your computer.
Then it's doing the same thing as if you're reformatting an actual hard drive in a real system.
So the file stays intact, it's everything inside it.
That is correct.
Okay.
So the disk image file is still the disk image file, and it doesn't do anything to the host side, to the Linux side, but to inside the virtual machine, you will be you'll be reformatting the hard drive. Okay. So basically, you can see that everything that I can do here, parts of the screen is not visible because it's the virtual machine wants to run in 1024 by 768, but the host is already running at 1024 by 768. So with all the bordering and the title bar and stuff like that, this is just not showing up anymore. And I have a lot of security essential things and monitoring. It just keeps complaining, so I can just tell it to you. It's at risk. Just keeps popping up. And it all goes away. Yep. So you can see all the things that I installed because inside this environment it cannot even tell that it is inside the virtual machine. Okay. And this is only 40 gigs of space. Okay. If you have an external hard drive, you can buy a 1 terabyte external hard drive. The really small ones for how much money now? 80 is less. Yeah. 1 terabyte. 50?
Yeah, you can buy like 2 or 3 for nothing. Yeah.
Okay, and then the enclosure itself is not that expensive. So go ahead.
I recently bought a 3 terabyte, I think, for 120.
Okay, but the 3 terabyte is a full-size hard drive. So you
Yeah,
cannot.
it's just a full-size hard drive. And
Yeah, so it won't power up from just a USB connection. Whereas something that looks like this, you can just plug into USB, and USB supplies both the power and also serves as the bus to
I also have one
transfer.
like that, but always complains that it's not getting enough power.
Yeah, well, with these HPs, it's kind of like touch and go. Depends on which which HP I'm using. I can have two identical HP computers. One will power up the external hard drive just fine, and then the other one would not.
I have two. There's actually two USB connectors on the back. If it
Yeah,
needs more power.
tethered. Yep. It really should not be like that because USB, the standard of USB, should be able to supply enough current.
It depends on the computer I'm using it on. Sometimes it works. It
Yeah.
also depends on which cord I'm using.
But it's handy. It's
Yeah.
just handy that I don't have to plug in an external adapter, in order to get this thing started. So this is only 40 gig. What you're seeing here is a old XP computer that's only having a 40 gig hard drive. With a 1 terabyte external hard drive, I can put a lot of virtual machines. I can have one for XP, one for 7, one for Windows 8, and so on and so forth. Okay. So for people who need to do this kind of thing, just because you have to support people who are using different operating systems, it's a really, really useful technology. Yep.
Is this a way that hackers get into other systems by creating virtual environments?
Get into.
I don't know, hack into, I don't know. a
No.
bank or-
Well, you can practice hacking, but you cannot actually use this to hack into other systems. Yep.
I actually use virtualization all the time when I have somebody else using my computer.
Mhm.
I'm very kind of paranoid about them screwing up my setup. So I
Mhm.
usually have a virtual machine running inside that they can use, and it won't mess anything else up.
So people who are basically you're putting a cage around other people who are trying to use your computer.
Yeah.
Yeah, so they can only mess up things inside the virtual machine, but not
And
the
in the
host.
virtual machine, if it's messed up, I can just format it and just reinstall real quick.
Yep, exactly. Yep. All right. So, are there any other questions about virtualization? I mean, because I think this kind of helps to demonstrate what it is about and why it can be useful. Yep.
Well, this is nothing to do with that, but yesterday I checked in your website.
Uh-huh.
There is a ICQ test link.
Uh-huh.
Somehow I click it, it goes to the Google Play Drive, and I download the system. And what they do is, well, actually in my computer, I have thousands of songs from years, CDs I transferred, and it's too much space. In the Google Drive, they allow me to do for free. And I just this morning, I finished from yesterday tonight, and it was thousands songs they saved from me, which is a good thing because every time that I want to.
You're basically talking about cloud storage.
ICQ test.
ICQ? Okay, ICQ, I'm not even sure whether people still use ICQ or not. That was something that I used a long, long time ago. Do they still have ICQ now?
I think it's.
What is it?
I think
Exactly.
It exists,
What's
but-
ICQ?
ICQ is kind of like Google Plus-ish kind of thing, Skype. It was a novelty when it first came out. By today's standards, like, why would we even consider using it?
You just use Skype.
Hmm?
You would just use Skype.
Yeah, Skype, or if you have on a Mac, you can use FaceTime. Yep. But at the time, when I remember I was using ICQ in 1998, and back then it was a big thing. Okay, back then, I can make calls to Canada for free, and back in 98, sorry, it was what, 15 years ago. Okay, so 15 years ago, things were a little bit different compared to today. Calling Canada was not having to pay for that was a big deal.
I think I stopped using it in 2001.
Sorry?
I think I stopped using it in 2001.
In 2001?
I think I was using Morpheus after that.
Okay. The really interesting part about this, this is definitely taking this a whole different step. Is if you look at this part here, is a VMware vSphere client, which is basically a program to connect to other virtual machines, that is accessible through the network. And this is a control panel basically for other virtual machines. So I'm running the control panel of another virtual machine inside this virtual machine when I do it like this. It's just kind of convoluted. In a way, it's convoluted. Any questions about this? Are there any Star Trek fans, in this class?
No.
Okay. Any Star Trek fan of TNG, the Next Generation?
Mm.
This is the holodeck technology. Okay, and there's no limitation of how many holodecks you can run inside, the ship, or how many levels you can run holodecks. In other words, I can run another virtual machine inside a virtual machine inside a virtual machine. As long as you have the resources to do it, it will let you do it. I actually tried that.
How far did you get?
Just 2 levels, nesting it twice, and that's already slow, way too
Yeah.
slow. Because the hardware acceleration only works for the first level. By the time you get to the second level, you lose your hardware acceleration ability.
Yeah, and then you're
Then it
still-
becomes like super sluggish.
Sounds like a great way to crash your PC.
No, it didn't crash. It was just
Well,
really
you
slow.
Create open this inside of this 20 times.
Yep. All right, so I can turn off the virtual machine. It's just like a regular PC. I mean, from every perspective, it's really just like a regular PC, except it is all virtualized. Okay. So after I get out of this one, I will explain another advantage of using virtualization, which I think is also a big deal. Okay, so I can just turn it off. You can see everything is really, really sluggish because even though the processor of this computer has virtualization technology, the BIOS, by default turns it off. Okay, so I'm just gonna wait for this one to finish shutting down, and then what I'll do is, where's my terminal? Right here. I can look at my processor and then try to figure out, whether it has acceleration technology. Oh, this is an i3, never mind. The processor itself does not support virtualization. Starting with, I think i5, does i5 includes virtualization?
Maybe.
I think i5 has virtualization technology already, and then i7 also. i7 will add turbo boost technology.
i5s and i3 even, they all have turbo boost now.
Yeah, but not when they first came out with the first generation of i3s do not have turbo boost.
This is the first gen right here.
Yeah, that's the first gen. All right, so getting back into the host, this is what we call the host environment. So whenever you run a virtual machine, you have basically 2 types of environment. The native or the environment that is representing the hardware is called a host environment, and then the virtual machine is called a guest environment, or guest operating system. So when we are now back to the host environment, how do I back up the virtual machine? You look at this one single file and you make a copy of that one single file. It's the same thing as imaging the entire hard drive from the virtual machine's perspective. Yep, go ahead.
You answered my question.
Yep, it's just
Yeah, you just copy it.
it's bit for bit imaging. So you just make a backup of this image file, and if anything happens to the virtual machine, if it gets infected at a later point, I can always restore that just by copying the file over, and I'm done. Yep.
Why don't manufacturers create virtual machines within a virtual machine, like within Windows? That way, if you get a virus or malware or whatever your virtual crashes, you can just delete it and put another copy.
Microsoft doesn't even want you to run Windows in a virtual machine. If you look at the licensing agreement of Windows 7, at least I think XP was the transition point. After XP, if you read the EULA, which stands for the End User Licensing Agreement, there's a clause specifically to say that you should not install the operating system on a virtual machine. Can anyone kind of guess why they do not want people to do that?
Because Microsoft.
Well, it's Microsoft, and Microsoft represents
Money.
for-profit companies, right? I mean, it's not a charity, so it's a for-profit company. So why do you think virtualization can potentially hurt the bottom line of Microsoft?
Duplicate.
Exactly, because now all I have to do is to duplicate this one single file and can give it to all my friends, and now they all have Windows XP with all the programs pre-installed. If I install Microsoft Office here, and I give the image file to all my friends, they'll all have Microsoft Office installed on their virtual machines. Do you see what I mean? Okay, and that is why Microsoft in their EULA specifically says you cannot install the operating system inside a virtual machine. Yep.
I think Google's is the only one who doesn't give you hard time with that, right?
Well, that's because
Everything that you work.
their business model is different. Google's their business model is not based on the licensing of products as much as generating revenue from advertisement. So they want people to go through Google to do things that are otherwise free. Okay, you can use Google Drive for free. You can use Gmail for free, and so on and so forth. But guess what? When you go through Gmail, they can now give you a little banner and say, "I see that you're arranging a travel to Hawaii. Let me tell you something about they will give you the right advertisement. Okay, they can actually see your messages, and then they can give you the right advertisement for whatever you're doing. And every time you click on an ad, like, oh, okay, I do want to join this whatever tour in Hawaii, that one click generates revenue for Google. So that's their business model. It's not so much of the licensing of the products. It is from advertisement. Yep.
What I'm trying to say, I don't know, is that when I transfer most of my, files from my computer to my terabytes, there was some license agreement issues. So I just click the accepted by my administrator, because as administrator I can do that. But once I went to Internet Explorer, I had some issues that they didn't want to install some updated other programs. So what I did, I just went to Google, everything to Google, and I went to MSN, to Firefox through Google. So once I did that, I don't have a problem with my Netflix, with my Hulu, using my terabyte. Because I think what I did, I didn't know. I used the terabyte as a virtualization, but I didn't know that I was doing that. I just trying to save the space that way. When I open it, I think most likely everything is through my terabyte. And when I use it and I open it and I go to the internet, it didn't work with my Internet Explorer. They didn't recognize the files that I had. So I just went to Google and I started doing that. It was pretty good.
Okay, well, as long as it works. All right, so are there any questions about what I just demonstrated, the virtualization thing? By the way, this is ultra defrag when you get to the download page. If you have 32-bit, download this one. If you have 64-bit, download this one. It's really kind of misleading because, I think they changed the phrasing. This is good. They used to call the second one, AMD 64-bit, because the instruction set was actually from AMD. But the instruction set is now used on Intel processors as well. So when people look at AMD 64-bit, they think, oh, but I have an Intel i7 processor. I should pick the next one, which is an Intel Itanium processor, which is not compatible with the i7. So now they've just made the phrasing a lot easier to interpret. 32-bit OS use this one, 64-bit use this one. Most people don't even need to touch this one, because unless you have an Itanium processor, which is like really archaic by today's standard, you don't need to use this one. All right. So, any questions? Yep.
How do you find out the bit again?
The what? Oh, inside Windows, you can go to the control panel, and then go to Systems. When you click that link, it will display the version of Windows, on that screen. I can't, it depends on the version of Windows too, so in XP it's a different way, and in 7 is a different way. Yep.
And another thing is, even if you have a 64-bit processor, if you're running a 32-bit operating system, you can't even use any 64-bit application.
From inside the 32-bit.
From inside the 32-bit operating system.
Right, correct. Yep. In fact, the one application of virtualization that people do not realize is when you have Windows 64-bit installed and you're running the old 32-bit applications, those 32-bit applications are quote-unquote running inside the virtualization environment as well. That's why they run slower than running natively on a 32-bit machine. All right. So are there any other questions about what we just talked about? I think I just took a kind of big digression from the notes, but I think it's a worthwhile digression because most people, before exposure to the virtualization, discussion, may think, oh, this is not very useful to me. But after this, I think some people are starting to change their mind and go like, maybe I have some use of the virtualization thing. But if you plan to do virtualization, you want your processor to support virtualization acceleration because it does make things a whole lot faster. Okay. Any other questions about the selection of processors? No questions? All right. All right, let's talk about the CPU fan and cooler selection. A CPU can run really, really hot, okay? Because even with an Intel i7 processor using the latest technology, 22 nanometer transistor size, it's still 77 watts, from a i7 processor. Now, 77 watts doesn't sound like a whole lot, right? I mean, when we had incandescent light bulbs, a 75 watt light bulb is not that big of a deal, right?
Yeah.
Has anyone ever touched a 75 watt light bulb, a regular light bulb, and get burned? Right? It's hot, okay? It is pretty hot. Now, a regular light bulb has a surface area of about a small pear, okay, a small orange, okay, which is not really huge, but it's still sizable. Your Intel processor, if you look at just the processor itself, the surface area is about this much. Okay, the exposure is about this much. I would call it, let's say a square inch. Okay, how do you compare a square inch to the surface area of a regular light bulb?
It's much smaller.
It's much smaller. Okay, so we are thinking about dissipating the same amount of energy, but through a surface that is a lot smaller than a regular light bulb. So you can kind of imagine that without a heat sink, without anything to help to get rid of the heat, the processor will get real hot real fast, and it will just die. Okay, well, or it will do a thermal shutdown these days. To understand, exactly how hot things can get, let's see if we can locate this YouTube video of AMD processor explosion. Yep, there you go. Now this one is kind of interesting. It really is interesting. Is this one here? Exploding overclocking extreme AMD Duron. This is like old technology, but it's really kind of interesting. All right, so this is a. Okay, let me see if I can get a little bit bigger. Explosive reviews. All right, so let's kind of put a pause right here. This is a typical motherboard, like a really old motherboard. And I'll just kind of briefly explain what these things are. So these two slots here, those are the memory slots. They are now a little bit smaller than kind of that size. I think they're about the same size, but they're a lot more dense, with more stuff. This whole thing here is the processor, heat sink, and then on top of the heat sink you can see a fan. So the fan turns, so to help to get rid of the heat. Okay. Look at this as the radiator of your car. Okay. And then under the heat sink, is the actual processor, and they're running some kind of really, heavy-duty benchmark program to make the processor as hot as possible. So he just, okay, did you see it? It just exploded.
That was pretty quick.
That was pretty quick. It didn't take long. Okay, let's replay.
Does that make the fan off?
It was gonna go in slow-mo.
No, okay. Poof. Okay, here's the slow-mo. Now the interesting part comes later, okay? So you might think that, okay, maybe the chip just kind of got really hot And what happens is, inside the chip, it's a completely enclosed environment. So when it gets really hot, things start to vaporize, and then the gas, kind of builds up the pressure. And then it depends on the kind of chip, okay? If you have a slow, quote unquote, melt down kind of thing, you can actually, the chip will crack first, and then from the crack it will release, the gases. So it doesn't really quite, quote unquote, explode. It just kind of literally lets the genie out of the chip. Okay, it goes shh, and then the chip is no longer functional, but you can still physically see the chip. In this case, the chip is gone. Okay, but not only is the chip gone, they will show a picture here, right here. The cameraman can use a better skill right there. Did you guys see what happened? It blew a hole on the table. In other words, the explosion force was big enough to blow a hole on the wooden table through. Yep.
I used to work in a building where we put PC boards together, and they were for lasers. So we'd be on the other side of the building, doing the amp part of it, and you'd hear this huge explosion, and the next thing you know, this rotten smell would come wafting through the building.
Yep.
Yeah, it was loud.
But the explosion was due to something that
Just testing.
kind of
They're
like
doing
this.
their testing.
Oh, when they're doing their testing.
Yeah.
Yep. You're ready to work for the national labs. The national labs has all kinds of dangerous stuff. Yeah, but this is really kind of amazing. That they blew a hole on the table. Okay, that part I was not expecting. I was expecting the chip to burn up and like maybe flaming and stuff like that. It just completely disappeared, and then it blew a hole on not just the motherboard. Remember, this whole thing is sitting on the motherboard first. Okay, so it has to blow a hole on the motherboard, and then has to force its way through the table. That's dangerous.
So that thing that you pulled off obviously wasn't screwed in.
It wasn't screwed in. Okay. What happens is when you put on a heatsink. Okay, so let's say this is the bottom of a heatsink, and this is the processor, or the top of the processor. In between, there's what we call thermal paste.
Right.
It's kind of like a kind of sticky stuff, that really helps to conduct heat between the processor and the heatsink. So it was probably just held together by the thermal paste, so it wasn't screwed down, and that's because they set this whole thing up just to run this experiment. I think when they ran the experiment, they did not expect something that was this explosive, because this is really dangerous. I mean, a lot of smaller caliber guns cannot shoot through a table just like that, let alone making a big hole in the process. In other words, this can really hurt someone. If it were a person, like under the table or something, that can really hurt.
Yeah, the fragments flying around very quickly.
Yep. Yeah, but the top was not, it's not like they put a brick on the top to force all the explosive forces downward. The top was completely open too, and that really tells you about the explosive power. And the processor is not really that heavy. Yep. And that's why heatsink is important. Are you guys convinced now? Having a heatsink on your processor is kind of useful.
We don't need it.
We already know. Okay, so when you consider a heatsink, there are several things you have to kind of think about. One is you don't have to buy one if you don't want to spend the money to buy one. When you buy a processor, it usually comes with a heatsink. Okay, at least Intel processors always package a heatsink, with and a fan, with the processor. Those will work okay, but they are usually not considered, great or particularly efficient. If you can keep your CPU working at a cooler temperature, it's better. Okay, because that basically makes your CPU last a little bit longer, and also we can also use turbo boost a little bit longer too. Because remember, turbo boost is internally determined by the processor based on its own temperature. When it gets up to a certain temperature, it would just basically say, okay, I don't have enough leeway, to run any faster, so I would just kind of drop down to a lower clock speed. when you're selecting a cooler, a CPU cooler, with fan selection, depending on whether the fan is built into it or not, you also have to kind of look at, how noisy those fans are. Some fans are particularly noisy. Usually, the larger the fan, the more quiet it gets. Okay, so I think the most common ones used these days is a 120 millimeter fan on top of a heatsink. Is that true? Or have they moved on to 140 now?
It depends.
It depends. Okay, I think 120 is still the most common, but with a higher end type, you might.
120 is actually it's still pretty big for a heatsink.
Yep, it is. I'll bring up to the next point.
120 is like that big.
A little bit smaller than that,
Yeah,
but
a
it
little
is,
bit about that big.
Yeah, it is still pretty big. Now some CPU coolers are tall, because they arrange everything kind of vertically. And I have this, personal experience is, I have a slide out motherboard tray, and after I put everything together, it will not slide back in because the CPU cooler was too tall. It just wouldn't clear the overhang, clearance of my motherboard tray.
At the side of the case.
Yeah, I could do that.
I had to do it once.
Oh, you had to do it once? Yeah, that was kind of good. Like I had everything assembled on the CPU tray, on the motherboard tray, and then when I tried to slide it back, I was like, no, this is not happening. I didn't want to modify my case either, so I took the CPU fan, the cooler off, put the whole thing in, and then put it back on. Cooler fins are actually very sharp, so you got to watch your fingers when you're doing it, because you can end up with cuts pretty easily. The fan blade itself is really sharp. Okay, so you don't want to mess around when your motherboard is powered up and running, because those fans, even though they're plastic, the blades are plastic, they are very sharp. Okay, so you can end up with a serious bad cut even with a fan. Yep.
I don't think it's so much that they're sharp. It's just the speed
It's spinning
they run
fast.
out.
They
'Cause
only
most,
spin at 1,000 RPM or so. Normally.
my CPU fan runs at 4,200 RPMs.
Okay, so there's a lot of momentum built up, to cut into your finger or whatever body part. Okay. The next, well, a lot of people understand all this stuff, so they would buy the biggest, baddest looking, CPU cooler, and then they save money on thermal paste, which is really the worst way of arranging everything. You really want to get, the best thermal paste that money can buy, because it's not expensive. No, undo. Control Z usually works. No. Edit, undo. I thought I just pressed Control Z and that would not work. Never mind. Okay. So thermal paste, which is kind of this stuff here between the CPU cooler and the processor, that actually is very, very important when it comes to the effectiveness of your CPU cooler. Yep.
I was curious, does thermal paste degrade over time?
Not the good ones.
Not the good ones.
Yeah, not the good ones. This one that I put here, is called Arctic Silver 5. I think there are other manufacturers making similar type of a thermal paste. They actually have micro actual metallic silver inside the paste itself. The way it works, with a normal thermal paste is when the processor heats up, this stuff actually is not as thick anymore once it heats up, and it actually has micro current, going, circulating, and it's that micro current that is conducting the heat, distributing heat from here onto this side, and it can make a difference. The Arctic Silver 5, the 5, actually means something. It has to do with, it's called a thermal resistance. In other words, the higher the number, the more difficult it is to transfer heat from one side to the other side. Okay, and Arctic Silver 5, the 5 refers to the effectiveness of transferring heat. From my personal experience, this is really the best, of all the common ones that you can purchase. Some people may have, access to like special thermal paste, that normal people cannot buy, but if you buy from Newegg or other places, this one works really good. Yep.
So the higher the number, the better the heat.
No, the smaller the number, Because if you look at the brand Arctic Silver, they actually make different type of thermal pastes. And I think one is called Arctic Silver 10. The 10 is actually worse than the 5 because the 5 and the 10 measures the resistance of thermal transfer. So the higher the resistance, the more difficult it is to get heat transfer to the other side. And it's only $16. I mean, for a small tube, you can say, well, but it's really just a small tube. Well, how much are you spending on your processor? A few $100. Your motherboard, another $100 or so. Your CPU cooler, maybe $30, maybe $50. So spending $16, really is the most crucial link between the processor and the heatsink. Is not really that much money. It's money well spent, if you ask me. Okay. Any questions? Yep.
We need a fan for this kind of things. How about the iPhone computers? I saw on the video on Facebook. Somebody get exploded the iPhone for the heat.
Oh, well, you don't have a choice, with an iPhone, because I don't think, a normal person can easily open up an iPhone and change the thermal paste inside it.
I don't think Apple would like it. I don't think Apple would like it either.
Oh, Apple, you instantly void your warranty, at the moment you try to pry it open. They will blacklist your name, put you onto a registry and go like, never sell Apple items to this person ever again.
They voided the warranty.
For life.
For
Yes.
life.
For life. You're not allowed to purchase
And in
any
your
more Apple
iPads.
products. Huh?
And in your iPads.
Yeah, hand in your iPads. They put your name on the registry. All right, so let me just kind of quickly go take a look at Arctic Silver. And that's the company. Oh, they have a 2 now. This is 5, that's a 2. When you buy a processor, or when you buy a CPU fan and a cooler, it usually comes with its own little tube of white, thermal paste. Don't use it. Because that stuff is really not good compared to, what you can purchase. And it really just kind of ruins the whole thing. You spend so much money on the processor, you spend so much money on the external, the add-on CPU cooler. You put your bad thermal paste on it, it just doesn't make any sense. Okay. And let me see if they talk about the specification. So let's just click this one. And when you look at the specification, just kind of magnify this part here. When you look at the specification, it doesn't give you the actual thermal resistance specification. Yeah, but that's not the actual,
Yeah.
because this is what I use, now I want to get this. Because the number is smaller. The lower the number, the better it is.
Wait, that one uses silver, like this ceramic. It's
Yeah.
ceramic.
I think it's ceramic.
That's what it was saying, like triple something.
Okay, let's take a look here. It's a high-density ceramic-based thermal compound for modern high-power CPUs, blah, 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 blah. Trilinear ceramic content. Okay, it's a composite of aluminum oxide, zinc oxide, and boron nitride to allow the thinnest possible bond line with modern processor.
So
In
you
other
can
words,
use it on your nose.
Updated, huh? I have not seen it, at other places. So cool. I don't really feel like having to disassemble my PC just to change the thermal paste. So I think I'll use this on my next project. Well, I can tell you about the other one, the Arctic Silver 5, combined with a $30 CPU cooler. $30 is not a lot of money when it comes to CPU coolers. You can spend a lot more than just $30. I was running with all 4 cores, at 100%, and my CPU temperature could not exceed 48 degrees Celsius. That was actually cooler than my older processor, which has an even bigger, CPU fan and cooler. So that really, helps. Alrighty, getting back to here. So watch out for the size, because some are just way too big, especially when you have a smaller case. It can be difficult. It can be difficult to assemble. All right. So moving on to hard disk drive, selection. There are different specifications you can look at. We kind of look at all these numbers already. It's just that we never really, have a written form of that discussion. The spindle speed refers to how fast the hard disk platters are spinning. When you look inside a hard disk drive, you can see, basically, a few plates. Okay, each plate is called a platter. Each platter is a magnetic type of a medium. In other words, it uses magnetism to store information. And then there are disk heads. Each disk head can read one surface. So on in this particular design, you have 1, 2, 3, 4, 5, 6, up to 6 surfaces. I'm not sure whether the top and the bottom actually are used to store data, but you can have up to 6 surfaces in this case, and therefore you will have six disk heads, in this particular system. The spindle speed refers to the rotational speed of the platter. Now, why do you think that matters? Just kind of think in the extreme case when it's spinning very slowly versus when it's spinning very fast, okay? How does it pick up data on the surface of the platter? The disk head itself does not move, right? So it's waiting for the right part of the platter to spin around, okay? So the faster the rotational speed, the faster you can get to the part that you want, that is actually storing the information that you're trying to access. And that's why the spindle speed does impact the overall performance of your hard drive. For most desktop hard drives, I think 7200 RPM is still the standard. Is that correct? Okay, and for servers, you can actually get ones that can spin up to 10,000 RPM. The faster the RPM, the harder it is to keep the whole thing stable and have the spindle, how do you call those things, bearings, to actually withstand the high RPM. IBM actually spent a lot of research money just to figure out how to do this reliably at a higher RPM. The capacity of modern hard drives, they're mostly measured in terabytes now, especially for desktop type of hard drives. 1 terabyte is 1 trillion bytes. That's a lot of storage. Reliability, it's measured in MTBF. We talked about this already, but I just want to write it out. It's called mean time between failure. For the most part, you really want to read reviews and not really just rely on the MTBF to evaluate a drive. I can share with you one experience with hard drives, that would kind of make it put you into the context, of okay, why do we need reviews? For many years ago, we put together our Moodle server. So Moodle is now virtualized inside the district, but at a certain time, it was basically just a box under my desk. So at that time, we contracted out the assembly of the server, the physical server, to a company, and they picked out Western digital drives that were intended for servers. Okay, so these were not things they can buy over the counter from Fry's. Okay, you actually have the special order from places because they are intended for servers. Within the first month, out of the 4 drives that we installed, 2 were failing already. Okay, so we replaced those 2. Fortunately, I had RAID 5 running at the time, so because of the redundancy, we actually barely had the whole system still running because we only got 2 drives left out of a 3-drive array, so it was just barely running. If I had one more failed drive, then the whole thing, it would lose data. So within the next month, another drive broke. Okay, and over a course of maybe 3 or 4 months, I had to replace the drives many times. And these were supposed to be server-rated hard drives. Okay. And by comparison, my own desktop computer, which had cheap, inexpensive, consumer-grade hard drives, I I have been running the same hard drives for at least a year at that time without any incidents. I mean, it was just running just fine. So later on, I found out why. The server drives were very temperature sensitive. Later on, we just added one extra fan to blow, to basically cool down the drives. So there's one extra fan to do it, and then the hard drive failure rate went down. Okay, not completely, but it went down. So that's one incident where the MTBF is not going to tell you anything, because the MTBF can be measured in a really nicely cooled environment, but your computer may not be, your computer case may not have sufficient cooling to recreate that type of lab environment. Okay, I never knew that hard drives, especially desktop hard drives, can be that temperature sensitive. Does anyone have any horror stories about the thermal sensitivity of your hard drives? No.
My desktop, yes, the old desktop,
Mm-hmm.
not for laptop.
Okay. Yeah, with laptop computers, it is a particularly big issue because with a laptop computer, they try to pack a lot of stuff into a tiny space, and that's why when I had my Dell computer, this is like really old. It had a Pentium 3 processor, but it would kill one hard drive per year. It's predictable. Okay, I buy a new hard drive, reinstall everything. Within 1 year, that drive would die. Okay, replace it with another brand, a different hard drive. Within a year, that hard drive would die too. It was just temperature. Eventually, I had to get rid of the laptop computer because I just could not afford to have a new hard drive every year. Yep.
Technically it was my mother who had a computer, and I don't know exactly what was wrong with it, but every single time we tried to get like a new coolant system for this thing, and it would work for a short time, and then it would just die.
Which part dies?
I think
The computer itself?
yeah, the computer would just shut off. It wouldn't ever turn back on, and then we'd replace the cooler because it was we'd replace the processor because that's what burned out. It would almost burn out every other time we tried to use it, and we'd replace the thing. We'd replace for a better end coolant system, the heatsink, everything. We'd replace the thing, and we'd get significantly better and better things, and it would always kill the thing.
Okay, I'm jumping a little bit ahead of time, but to answer your question, it can be the overall cooling of your case.
Yeah, we just ended up kicking it out at that.
Yeah, if you look at the case of a computer, it's the power supply is usually up here, and then you have your motherboard, pretty much here because it has to close to the edge on this side. And most systems would have, the hard drive, mounted here or so. Okay, so the question now is, how do you arrange the fans of your entire system so it makes a very effective cooling system? The one thing you want to do is to make sure that or I want to do is I make sure that one side is only for drawing cool air in, and then the other end is only for drawing cool air out. Okay. In other words, I don't have in and out kind of mixed. Okay. The reason why that is the case is because if I have, let's say, another fan here that is drawing cool air in, then it can short circuit. Okay. So the cool air that's coming in can immediately be sucked in by the power supply and then drawn out again. What about these components in the inside? It never gets cooled, right? And if I have cool air coming in through here, but I have an exhaust fan coming, blowing the hot air out, it can short circuit. So things in the middle will never get cooled. So that's why the arrangement of the airflow is very, very important. It has nothing to do with the number of fans, because if you have a lot of fans, but you're not actually having air to go through the entire system, effectively, it's not going to cool down the components in the inside of the case. Yep.
I can definitely vouch for that. I had a computer a while ago. This was when XP64 first came out, or 2000. It was 2010, 64-bit, and it was in my dad's back office kind of thing. And this was down in LA in the summer, and so that room would be anywhere from 100 degrees to even up to 120 degrees. and it would just start blowing its equipment as soon as you started using it.
Mm-hmm.
And my dad, not being terribly technologically literate, just thought, oh, I'll just add more processors because we had a big case with a bunch of slots. And like you said, there was a lot of like short circuits and stuff like that with the airflow, and so I ended up doing basically what you did, streamlining the whole process, and it ended up making it so the computer stopped failing even when it was 120 degrees in a room.
Right. Yep. Yep. And this is one reason why putting your own PC together can be both a challenge, but it can also be helpful because now you have control over all these little details, where whereas if you buy it from a manufacturer, sometimes it's not even accessible. They can flip the direction of a fan. All right, so that's the end of today's lecture. I'll see you guys next Tuesday. Have a nice weekend.
Was those mineral oil ones that we talked about earlier?
Yep. Dunk it into a tank. Actually, in that